Hello students, this is Ms. Barr with another simple bookkeeping and accounting nugget. Number 3, the accounting equation. So let's get right to it. The accounting equation shows the equality of assets owned to the liabilities and capital owed to external parties. And as we know, it is expressed as assets is equal to liabilities plus capital, or A is equal to L plus C. Another name for the accounting equation, that's correct students, is the balance sheet equation. Okay students, let's take a look at assets, liabilities, and capital. Assets are resources owned by the business. Examples, cash and stock of goods. We also have liabilities, which are obligations of the business. Examples, loans. Capital can be defined as cash and other assets that are invested in the business by the owner, either to start the business or during the life of the business. Now, get a pen and a piece of paper so that we can use the accounting equation in a few questions. Question number 1. 12,000, your assets, liabilities, 1,000. What's the capital? All we have to do is subtract the liabilities from the assets. So the answer is 11,000. Excellent job. Question number 2. Our assets are missing. As we can see, we have our liabilities and capital. So in order to calculate our assets, we just simply add the 2,000 plus 13,200. Our assets total, 15,200. On to question number 3, our final question. What's the total for our liabilities? So in this case, we would take our capital away from the assets. And you guessed it, our liabilities total 11,500. Excellent job. So remember, it's as simple as that.
Here's what we're looking at today. Just to finish off what we started yesterday, we're going to go over graphs of quadratic graphs, specifically those that come from BGCSE past paper questions. And so our objective for today, by the end of this lesson, you will be able to solve and work past BGCSE paper questions involving graphs of quadratic functions. And so I am going to switch things up a little bit. Instead of using my PowerPoint, I am going to share my document. Okay, awesome. So you can see my table now where I'm working from. And we are going to go ahead and get started with the same question we ended with yesterday. And I want to do the entire question over. So we're going to start from the very beginning. Let me pull it into screen so that you can see everything. All right, so here's the question, and I'm going to read through it. It says, for the equation y equals x squared minus 4x plus 3, copy and complete the table of values below. And we see we have our table, but I really only need to find 2 missing values. I need to see what happens when x is -1, and then what happens when x is, so those are 2 values that I'm working on. B says use of 2 cm to represent 1 unit on the x-axis and 1 cm to represent 1 unit on the y-axis. Draw the graph of the equation. Question C, from your graph, write down the values of x at the point where y equals 2. D, draw the line of symmetry for this curve. E, on the same axis, draw the graph of y equals 2x minus 3. And F, write down the coordinates of the point where the two graphs intersect. And so just a quick breakthrough, we're going to go through each part of this question together. For question C, where we're asked to identify the points, as well as question F, we're going to have to do some estimating in terms of finding those specific points. And then for question E, we're going to use the slope-intercept method of graphing this line. So let's go ahead and get started. First thing I'm going to work on is question 8. And I have some paper and we're gonna write. So, all right, A, and I'm writing the function first, y equals x squared minus 4x plus 3. I have my function written and I know that I need to find the first two values. So I need to know what happens when x equals -1. So I'm going to substitute y equals -1 squared minus 4 plus 3. So all I've done so far is just substitute my x value into the function. Now next step, y equals, well, I know -1 squared -1 squared means -1 times -1, which would be +1. Then it's the -4. So -4 times -1 becomes +4 plus 3. I think I might be having a slow internet connection. If so, please bear with me. So I noticed it just said unstable connection. All right, yes, Gabrielle has already given me the answer, but I'm just going to finish this up. So y equals 8, and again, I have the point -1, 8. Now I'm going to look at the second value. What happens when x is equal to 2? Substitute it in, y equals 2 squared minus 4 times 2 plus 3. Y equals 4 minus 8 plus 3. Y is equal to, let me just confirm that. All right, y is equal to -1. And so my second point is 2, -1. All right, and so what I would do on my graph, and I'll show you that in a bit, I would copy and put my table maybe in this corner here. And so you're going to see that a little bit later. But for the time being, I can write it here, but I know that I have to copy that. I have to copy this table because the question asks me specifically to copy the table. So I'm not going to leave it here. And I see sometimes students just leave it on there, maybe their BGCSE question paper or their exam paper. The instructions specifically said to copy it, and so I'm going to do that later. Let's move on though. Now B says using a scale of, and I put the question back to how it should have been on the BGCSE. Using a scale of 2 cm to represent 1 unit on the x-axis and 1 cm to represent 1 unit on the y-axis, draw the graph of the equation. So I'm going to, first of all, before I even draw the graph, I have to draw my axes, my x-axis and my y-axis. Now what they tell me about the x-axis is that it has a scale of 2 cm to represent 1 unit, which means instead of writing a number at each line, I'm skipping a line. And I know that it needs to go from -2 to 5, my x-axis. I know that my y-axis, the lowest it needs to go is -1, and the highest it's going to have to be is 15. And so if I look at my graph paper, and this is very similar, almost exactly the same paper that you would get for the BGCSE. If I look at my graph paper, I know that I'm usually used to drawing my axes in the middle of the page. But from your experience, you should know that if we drew my axes smack dab in the middle of the page, there's no way I can get 15 to fit. And so I am going to move my axes and shift it over a little bit. And so I'll bring my, definitely gonna bring my x-axis down some. All right, there you go. Going to bring my x-axis down. Make sure I label it before I move on, because I don't want to forget that. All right, now instead of putting my y-axis in the middle, I'm also going to move that over a little bit to the left. All right, and I'm gonna go ahead and draw this. Again, making sure to label it before I move on to anything else. So I have my axes drawn. Now I'm going to go ahead and put in the units. Again, just to remind myself, the question told me to do 2 centimeters to 1 unit for the x-axis. So I am not going to label every single unit. So this won't be 1. Instead, I'm going to skip and label every 2 lines. So 1, 2, this becomes 1. 1, 2. That gives me 2, 1, 2, 3, 1, 2, 4, 5. And then I'm going to repeat the same thing on the negative side. Negative 1, negative 2, negative 3. Now looking back at my table, I know my y values have to go up to 15. And then they have to go as low as 1, negative 1. They tell me 1 cm to represent 1 unit. And so I'm going to label that. Every unit is going to get a line. Every line, I'm sorry, is going to get a value. So this becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's sufficient, and everything is not on the screen, but so you can see I did go ahead and draw everything. All right, put in all of my points on the axes. So next step, we're going to go ahead and plot. So I'm going to switch out. I already had this one drawn up. And what I want you to take note of is how I put my table in the top right corner. So just as they've asked me to, I've copied my table, my completed table, and it's on my graph. So I'm going to use this table now to plot points. The first point I have is negative 2, 15. So I find negative 2 on my x-axis, and I'm going to go up to 15. Negative 2 up to 15. That's my first point. Negative 1, 8. So negative 1 up to 8. I have my second point. Then, let me pull it back so you can see. 0, 3 is my third point. When x is 0, y is 3. That's this point here. Then I have 1, 0. So x is 1, y is 0. My next point is going to be 2, negative 1. Then I have 3, 0. Then 4, 3. 4, 3. Okay, and when x is 5, y is 8. So it's my final points. And I have all of my points that have been plotted. I just need to connect them. Before I continue, let me know, can you see Can you see my graph clearly? I don't know if I have on too much light because I can turn some of the light off. So let me know if it's too much. But these are my points, and before I even connect them, I can see that these are going to connect to give me a smooth curve. All right, and I know it's not going to be 100% accurate, but it is definitely going to be a smooth curve. All right, so let's go ahead and connect my points. All right, there you have it. That's my parabola, right? Yeah, I know my internet is lagging. Like I said, yeah, my connection is moving slow. Like I said, I don't know what's going on in my area, but we did have the internet out overnight. When it comes to the axes, yes, I did go over to 16 instead of stopping at 15. That's fine, especially since they didn't. If I go back to the question, here it is. There you go. In the question, they never specifically told me what values to include on the X and Y axis. And so I was left to determine which values I wanted. And so it's fine if I included one more. All right, let's move on now. Before I move on, though, to the next part of the question, I always want to make sure if I know the name of the line or the curve that I've drawn, that I label it. So I'm going to just switch this sideways and label my curve y equals x squared minus 4x plus 3. Okay, so looks good so far. Now let's look at question C. Question C says, from your graph, write down the values of x at the point where y equals 2. So the first thing I need to do is identify where this line y equals 2 is. And I want to see where does my graph cross or intersect with that line. And I'm going to identify the x values at those points. So I'll take my ruler, and I'm not going to draw this line. I'm just going to put my ruler to where the line should be. So I'm going to put my ruler on the line y equals 2, which I know is the horizontal line that goes to the point y equals 2. And I'm trying to see where my graph intersects with that line. And I have two places. I'm going to put a dot. Let me use my purple pen so you can see it a little bit better. I'm going to put a point there, and that's going to help me to identify what the x values are at those places. Okay, so I have 2 points. Now I'm going to have to estimate what the x value is. But here's what I do know about my scale. I know that from this point, which is 0, here is 0.5. So that means that each individual line must be 0.1. So this 0.1, 0.2, 0.3, 0.4, and then 0.5. And so if I just estimate, well, I'm not even estimating, I'm going to look clearly at where this is, and I count, that's 1, 2, 3 of the small lines over. So that's 0.3. That's question C. And I'm writing it right at the top. X equals 0.3. And let me find the second one. That's my first point. Now I'm looking at the second one out here. I know that it has to be between 3 and 4. It's more than 3.5. So if I just count 3.6, count the lighter shaded lines, 3.6, 3.7, 3.8. I'm about 3.8, so I'll put x equals 3.8. Okay, so still trying to go a little bit slower. This question says, from your graph, write down the values of x at the point where y equals 2. So maybe if it'll help, I'll draw that line y equals 2. So for the benefit of everyone, I'm going to draw the line y equals 2. That's this line right here. And I can make sure I label it. I noticed that this line y equals 2 is going to intersect with my graph in 2 places. This question is asking me to tell at which 2 places does my line y equals 2 and the actual curve that I drew, where do they intersect? And I've indicated those 2 points. This point here, and then this point here. And what I have to do is estimate the value of those 2 points. Let's look at the very first point. This very first point here. I know that it's less than 0.5 because this dark line here is 0.5, and so I've estimated it to be a little bit less, and so I chose the value 0.3. If you were able to look at it a little bit closer, you would see the lighter shaded lines. So I chose 0.3 for this value. Now, if we move over to our second value, I know that it's a little bit more than 3.5. It's more than 3.5. 3.5 is this dark line here. And so I counted 3.6, 3.7, 3.8. I counted the lighter shaded lines to get this value. But even if, let's say you're drawing it in, no, I counted those lines and it's really an estimation. And so you're going to have to estimate a value that's between 0.5, 3.5 and 4. And it's always a good guide to use these lighter lines because these lighter lines do have a value. And so if I started at this, if I started at 3.5 and I counted over, here's a line here, that's 3.6, 3.7, and then 3.8. All right, so I'm just going to pause for a second to give those persons that are drawing a chance to get their graph together. Okay. So now let's look at back at my graph. Question D. So I've answered A, B, and C. Question D now says, draw the line of symmetry for this curve. Line of symmetry. Remember now, my line of symmetry always goes through my maximum point or my minimum point, depending on which one I have. In this case, I have a minimum value, the lowest value on my graph. And so my line of symmetry is going to go through that point. So I'm going to draw a vertical line that goes through this particular point here. And because we're talking about line of symmetry, I'm going to draw a broken line. All right. So that's what my line of symmetry looks like. And it does not matter that these two sides or two halves of the quadratic aren't exactly the same. What I'm looking for is a line that goes through my minimum value. Because the reality is that if this curve were extended, it would in fact be a symmetrical curve. And I'm going to label my line of symmetry. I know it goes through x equals 2, and so this line's name is x equals 2. All right, let's move on. Now, part E says, on the same axis, draw the line y equals 2x minus 3. Now, what's good about this line is that it's written in slope-intercept form. And so I can easily pull out from this the y-intercept, and I can also pull out the slope. So I know that in this case, my y-intercept is going to be that constant value that stands alone. And so in this question, the constant is this term right here, -3. I also know that my slope is the coefficient of x, and so m is equal to 2. But instead of leaving it as is, I'm going to put it over 1. And putting it over 1 is going to help me when I graph my line using the rise over run method. Because I know this tells me to go up 2 units and then to the right 1 unit. And so that's why I put it as 2 over 1 instead of just 2. I see your question, Joy. And so when you do draw your parabola, your line, the curve that you draw should easily go through all of your points. If it doesn't, check to make sure you plot all of your points correctly and that you labeled your axes correctly. So now we're going to finish this up. I know that my y-intercept is -3. And so I'm going to start with my first point at -3 on the y-axis. It's going to be my first point. Then I'm going to use the rise over run method to find additional points. So I'm on my graph. I'm going to identify where y equals -3 on my y-axis, and I'm going to put a point right here. That's the very first point on this new line that I'm drawing, y equals 2x minus 3. All right. Now I'm going to use my slope. The rise over run method tells me to go up 2 units and then to the right 1 unit. What I need you to keep in mind from my x-axis, because I did 2 centimeters to 1 unit is really going to be 2 boxes. Okay, so let's do that. Let's go up 2 units. So from -3, I'm going to go up 2 units, 1, 2. But on my x-axis, I know that 1 unit is going to be all the way out here. So that's my first point. And then I repeat that process. 1, 2, and then out here. Over 1 unit. Repeat it. 1, 2, and then over to the right 1 unit. I have more than enough points at this point. So I'm going to take my ruler and let me just show you where my 4 points are. This is a point. This is a point. This is a point. And my last point. So taking my ruler and I'm going to connect those 3 4 points. All right, and I'm going to label this line. I equals 2x minus 3. Good stuff. So that was question E. I hope that that was a lot simpler, that everyone was able to follow that, because it was really just a continuation of what we would have done last week with the linear functions. So you do what you prefer. You know, some persons are going to say, I prefer the table method, and some persons prefer using the slope-intercept method. Whatever you prefer is fine. Okay, so let's move on now. Question F says, write down the coordinates of the point where the two graphs intersect, which means I have to identify where does my curve intersect with my straight line. And I'm gonna bring back my purple pen. And I'm going to identify the two places that they intersect. That's here and here. So I'm just pausing to give you time to get what you need on your graph. So Joy is asking, how did I find E? Did I make y equals to 0? No, y wasn't equal to 0. I used my y-intercept. That's waiting for this to come in. I know it's lagging. That's this value here, -3. So I went to my y-axis and I plotted a point at -3 on the y-axis. Or really, if you want to look at it in terms of it being a point, this is where x is 0 and y is -3. That's the value I used. Okay, and so that's where I started. So I'm just giving you a chance to catch up. All right, so let's move on now. Okay, question F says, write down the coordinates of the point where the two graphs intersect. And I've already identified the two places where they intersected. That's here and here. And this is going to be an estimation because it doesn't fall squarely on any specific point, and so I'm estimating. This question F. For this one, x is going to be 1.3, and my y is going to be -0.4. That's my first place where they intersected. And again, I'm estimating. I know that it's not, if we look here, because we could see it still, if we look at it, it's not fully 0.5, because this would be 0.5, but that's a little bit over. And so I estimated it to be, it's not 1.5, so I estimated it to be 1.3. And then the same thing here. It's not at 1, and so I know it's somewhere between 0 and 1. And so I estimated it to be -0.4. And let's look at the next one. Same thing. I'm going to go with 4.7. 6.4. Now, the good thing is all of these questions won't be as crazy where you have to estimate. A lot of the times they're going to fall on easily identifiable points. All right. So here's what we're going to do. We're going to look at our next question. And I'm going to pause and give you some time to get started with this question. All right, here's our second question. Just want to make sure you can see everything. All right, there you go. Given that y equals 8 minus x squared plus 2x, copy and complete the table of values below. And then using a scale of 1 cm equals 1 unit on both axes to draw the graph of y equals 8 minus x squared plus 2x. And then C, on the same axis, draw the graph of y equals 4 minus x. D, write down the points of intersection. E, draw the line of symmetry. And then F, write down the gradient. So what I'm going to do, I'm going to pause, give you all some time to start this question. If you have any questions while you're working right now, it'll be a good time for you to post them in the Q&A for me to assist. Or you could post them in the chat if you need as well. So I'm going to pause and you're going to begin this question on your own. So right now you are working on this table. Specifically. So I see Deonta already has her first value for our table that she shared in the chat. She has her first value. She knows that when x is -1, y is 5. Feel free to share your values in the Q&A section if you want my feedback. But right now you're working on completing the table, and then if you have graph paper, go ahead and move on to labeling your graph. Okay, so let's start this question. I'm going to find the missing values for A and B. And I start by writing the function. Y equals 8 minus x squared plus 2x. The first value for x that I'm using, x equals -1. So y equals 8 minus -1 squared plus 2 times -1. So all I've done so far is just substituted in my x value. Now I'm going to start to simplify. Y equals 8, take away, well, -1 squared just becomes 1. And then +2 times -1, -2, or take away 2. So y is equal to 5. So my first value, and I'm going to put it on my table for now, is 5. My first value is 5. And now let me repeat the same process for when x equals 2. X equals 2. So y equals 8 minus 2 squared plus 2 times 8. Sorry, 2 times 2. Two times 2. All right, so now we're going to simplify. Y equals 8, take away 2 squared becomes 4, plus 2 times 2 is also 4. So 8 take away 4 plus 4, y equals 8. So I'm going to go back to my table and I'm going to write that there for the time being. But I know that I have to copy this table onto my graph. And so this will not stay here. I want you to notice that I'm taking my time to answer every part of the question on the graph. Okay, so now that I have that done, the next thing they say to me is use a scale of 1 cm equals 1 unit on both axes to draw the graph. And so I'm going to set up my graph. And I know that this one, it's straightforward. If I look at the values, it's okay if I just put my axes in the middle of the page. And so I've already done that. And this is what it's going to look like. And note that I have my table at the top of my graph. Okay, so I am going to so remember when we were writing our coordinates, we always use brackets. I don't want to ever see you just put 2 0. Make sure you put brackets around those. All right. So because we have to be mindful of the time, let's move on. I'm going to go ahead and plot my points. So while you're still drawing, you can continue to draw. I'm just going to quietly plot my points. I wrote the wrong thing. Oh, yeah, this first point I plot wrong. It should have been -7. All right, and so I have all of my points, and I'm going to try my best to connect them all in a smooth curve. Next question, let me just put this working back on the screen. The question did say plus 2x Drexel, but if you look at my working, when I substituted the -1 into the equation and I simplified this portion of my function, +2 times -1 gave me a -2. And that's how I got take away 2, you know? So that's how I got 8, take away 1, take away 2 to get 5. Or Drexel. I don't want to say your name wrong. All right, so now let's move on. I have all of my points that have been plotted on my graph. Just taking a second to focus. All right, there you go, we focus again. So now that I have all my points plotted, I'm going to try my best to use a steady hand and connect all of my points. I don't like how this looks right here, so I'm just going to clean that up. All right, that looks a little bit better. So to finish this up, I'm going to make sure I write the name of this line. Y equals 8 minus x squared plus 2x. Cool. So let's look back now at the question and let's take a look at what we've done so far. We've completed A because I have my table. I have my table on my graph. We've completed B, which asks me to draw the function y equals 8 minus x squared plus 2x. Now C asks me to, on the same axis, draw the graph of 4 minus x. And even though this isn't written how you maybe would like to see it, I still can identify various parts. I can identify the slope and I can identify the y-intercept. So let me just do that. My slope M is equal to -1, and my Y intercept is equal to 4. All right, so I can now easily take